All right, students, before we get into the brief demonstration of when I had lithium and carbon and aluminum and sodium in water, I just wanted to give a brief overview of what's going on for these valence electrons. These valence electrons, the Lewis dots represent those valence electrons. Those electrons are the ones on the outside energy level. So I'm going to briefly make my screen bigger. So if I was to draw a Lewis dot model of hydrogen, I'm not going to pay attention to the neutrons at this moment. I would have one proton, I would have one electrons because the energy, and I'd have one energy level. So that inside right now is just going to be our nucleus. And then if I moved up to lithium, lithium has a total of 3 protons and 3 electrons. If I was to draw that Bohr model would have 2 on the first energy level and 1 on the outside level. Just like hydrogen had 1 on the outside, and so does lithium. So then I move up another energy level, and I'm going to have 11 protons, and I'm going to have 11 electrons. So those on that second energy level, I would have 8. That first energy level would have 2, and then that outside level would have 1 valence electron, as I'm trying to do this in mirror image here. So 1 valence electron, and potassium, and so on. So these Lewis dots, if I was to draw the Bohr models for all of these elements that I have drawn here, you would see that every single one of them would have boron would have 3 on the outside, aluminum would have 3 on the outside, gallium would have 3 on the outside, fluorine would have 7 on the outside, chlorine would have 7 on the outside, bromine would have 7 on the outside, each one of those. But in order to make this easier, because mostly in chemistry we're just talking about those outside electrons, we're really focused on just those ones from now until pretty much the end of the semester. So you can imagine on the periodic table, if you're looking at the periodic table, you've got this first column. This first column, also known as a group or a family, will all have 1. The second one will all have 2. And then we ignore that middle area, though we skip all across those transition metals because those transition metals are really strange. Sometimes they give away different numbers of electrons. We're not going to get into that in this class. As we move over, you can see 3 or 13. It's 3A or group 13. All of these have 3, 4, 5, 6, 7, 8. And then helium is one of those weird exceptions because it's not reactive. It's going to act like a noble gas. All of these are going to also have 8. And this also has a full shell, but because that full shell only has 2 electrons, so that first shell is only 2. So that's a little overview of remembering what the Lewis dot is. And whenever I do this demonstration that you're about to see in this video, you'll see me do lithium, carbon, aluminum, and sodium. And thinking about what's going on, we've got some metals reacting with water, we've got some non-metals maybe reacting with water. So think about these things as you continue to watch the demonstration. All right, so now that you've had a chance to really look into the Lewis dot structure stuff, here I have a little demonstration for you in my backyard. And here we are. I'm setting you up with seeing some lithium and water, some carbon and water, some aluminum and water, and some sodium and water. So I've got my water here. I've got each of those things here. I've got some lithium. I have some carbon. I have some aluminum. And I have some sodium. All right, so I'm going to pour each one of these. We'll do these reactions one at a time, but I'll put each of these close to the camera as we are doing each one. I'm going to start with the lithium. So we're going to open up the jar here. I'm going to move the lithium a little bit closer to you so you can have an opportunity to see what's going on with this potential reaction. So I've got a piece of lithium. I'm going to use a knife to cut it. here we go. You can kind of see a little bit. It's a little bit kind of a silvery metal, and it is a little bit hard to cut. I can cut it with a regular knife from my kitchen, but you can see here there's a little bit of silver that kind of peeks out when I cut it. We'll talk more about what's going on there. And I'll close the lid of the lithium. And here we go. Here's your lithium. So you've seen that the lithium is reacting with the water. It's bubbling. It's warm on the sides. It's producing a gas. That gas is not because all of a sudden I added heat to the jar. So it's not like the different particles or the molecules are all of a sudden getting heated. They are getting heated because there is a reaction happening. So we'll talk more about that whenever we talk about chemical reactions. But you'll see it's kind of dancing around. It's moving around. You can kind of, the smell that's coming off of it, it's not very pleasant to smell. It is hydrogen gas that is coming off of that reaction. And now we've got some carbon. So carbon is, got this right out of my fireplace today. Here's the water. So here we go, got the carbon. Just gonna drop it right in there. All right. Please notice there's no bubbling, nothing's happening. It's not getting warm, it's floating actually, meaning that it's less dense than the water, it's not mixing with the water. All right, thinking about carbon. So there are other things in there besides carbon, but it is mostly carbon. So there's our carbon. And then here we have aluminum. So here we got our aluminum jar. Got some aluminum from my drawer in the kitchen. And here we have aluminum. So, is anything happening? Nothing's happening. It's not bubbling. It is a metal. Lithium is a metal. Aluminum is a metal. Nothing's happening. No bubbling, nothing. And then we've got sodium. So if you are already figuring out that the sodium might be a little more reactive than that lithium, that might be a thing. So here we are. Gonna get a piece of sodium from our jar here. All right, here we go. I cut it in half. It's a little bit silvery, but most of it's pretty silver. I screw on that lid. And here we go. we go. So guess what? Sodium is more reactive than all of those. I wonder why. We'll talk about that when we get into chemical reactions.